Starting with version 4 of AcqKnowledge, you can perform event-related analysis on skin conductance data. The following screencast is a quick overview of the capabilities of the software. You need the recording where we have both the skin conductance data and also the markers that correspond to the stimulation events. You can send digital markers over the parallel port using a program such as ePrime, DirectRT, or you can also do that via SuperLab. And what you get is these new channels, as you can see below here, underneath the skin conductance data. In this particular example, we have two channels of digital marker data. One corresponds to stimuli that were categorized as scary, and the other channel corresponds to clap sounds. So in this particular experiment, two different types of sounds were played to the participant, and we're looking at the skin conductance responses following these sounds. The first step is to have AcqKnowledge convert these pulses to stimulation events, to markers in AcqKnowledge. And there is an automated procedure to do this. In this particular instance, we have received information on digital lines 8 to 15. You can also choose specific channels if you have been receiving information on analog channels. This particular setting is for more advanced work where you're sending all kinds of channels of information corresponding to markers. We do not need to do anything right now. And you will see now up here where global markers are placed, these light bulbs called stimulation event markers will appear. And each of them has a label. This one has a label 1 and this one has a label 2. And as you can see, they correspond to the first and the second channel of stimulation data respectively. At this point, we can look at the preferences for skin conductance analysis, and they're found under Preferences under Electrodermal Activity. We have two different ways of constructing the phasic electrodermal activity waveform. For right now, we'll just stick with the high-pass filter, and we can specify the threshold for what will be a skin conductance response, and then also a rejection threshold, so a certain only certain percentage of the maximum skin conductance response will be accepted. All these settings will be discussed also in the detailed tutorial on skin conductance analysis. For right now, we'll just choose these defaults, and we can go ahead and run the electrodermal activity analysis. There's still more settings here. We can specify which channel of skin conductance we're using, and then whether to construct a phasic signal or use your own. And then we can specify the stimulus event type. In this case, it's stimulus delivery. It can be placed anywhere. And then this here allows us to specify what is the minimum and maximum separation between the stimulus event and the onset of skin conductance response. Because if a skin conductance response occurs 100 milliseconds after the stimulation events, that's physiologically not possible. So this allows you to rule out responses that occur too early after the stimulation events, and they will not be considered specific to the stimulation events. And all the same, responses that occur too long after a stimulus will no longer be considered specific to this stimulation events. So what the software will do is it will score the electrodermal activity data and provide you with two types of skin conductance events, specific and non-specific. The specific ones are those events that have been above the specific threshold that you set in the preferences, and also within a certain time interval following the stimulus presentation. And non-specific skin conductance events will be all the other events. In addition to marking these events and obtaining data for their amplitude, rise time, latency, etc., we'll be able to obtain data between pairs of events that mark different experimental conditions, as we can see with these flags over here. This will allow us to look at the frequency of specific and non-specific skin conductance events within each condition of the experiment. So we'll go ahead and run the analysis now. And these open brackets that you see appearing, they denote the onset of skin conductance events, while the closed brackets are the end of the skin conductance events. An Excel file is generated with the results. We'll just quickly go back to the data here and look at one example of a skin conductance event. Let's zoom in on the data and auto-scale the waveform. So we can see here we have the onset, the end, and the peak of the skin conductance event. These are marked on the channel that had the tonic skin conductance recording, so the row skin conductance recording. And then if we scroll further, we can see an event that is marked as a specific skin conductance event. It has a little flag on the sweat drop, and it's also red. As you can see, it follows a stimulus presentation, but it follows it within the time period that we had specified in the settings. So this one, for example, has occurred too late after a stimulation event. It is not considered a specific skin conductance event. This one here, on the other hand, is considered a specific skin conductance event. If we look at this one, it's happening just about the time of the delivery of the stimulus, and it is not considered a skin conductance event. Let's have a look at the table that's generated. It contains the amplitude, most importantly, as well as other statistics for each stimulus that did result in an event, in a specific skin conductance event. So we can see what was the stimulus label, and as you remember, 1 corresponds to scary events, and clap sounds are number 2. We can see which stimulation instances did not result in a skin conductance response. And we have this table here that gives us the amplitude and the magnitude, as well as the frequency of response to the different types of stimulation. And the amplitude is the average of all specific skin conductance responses. The magnitude is calculated when we take all stimulus presentations and we average the non-responses, which are 0, and the responses as well. And we also have the frequency. So this gives you a very good picture of the type of responses we got to these events. As we can see, we got more responses to the scary events, and the amplitude and magnitude were both higher. This table here provides information for the rates of specific and non-specific skin conductance responses in the 2 different conditions of the experiment. A detailed description of the implementation of this analysis is included in the software